This is part 2 of the recording for chapter 10. In this class, we will mainly look at the value of perfect information, or the value of clairvoyance. Okay. By now you should know perfect information is just another term for clairvoyance. Okay. First, we'll look at what is the value of perfect information for Kim in the party problem. So we're using Kim's party problem to illustrate how to find value of perfect information in a particular decision situation. Then we will look at the value of perfect information for another person who we call Jane in the same party problem. And then we will look at yet another example of a risk-neutral person's investment decision. So looking at these three examples will give you a clear idea of about the concept of value of perfect information, as well as the method to look for the value of perfect information in any decision situation. Now, at the end of the video, we will also look at the fourth example that is drawn from your homework, or if it is not in your homework, you can simply treat it as another example to illustrate the idea of value of perfect information and how to find it. Okay, so that is just an outline of this recording's structure. So a quick review about something we learned in the last recording is to find Kim's value of the party. Okay, in order to find Kim's value of the party, we need all the information that you see on this slide from Kim. Okay, we need Kim's value of the prospects in the party problem. Okay. We also need Kim's belief about the weather on the party day, which is represented by this set of probabilities. Okay? And the third piece of information we need Kim to give us is her yield curve. Okay, so this set of dollar values, this set of belief, and this yield curve are the three pieces of information that Kim needs to give us. And after we got the three pieces of information from Kim, we are able to help Kim decide what is the best location to have the party based on her belief and her values and her preferences. Okay. The way to do that is, again, just a review. First, we need to what we're looking for is the value of the party problem given this belief and these dollar values. The first thing I want to clarify is that when we talk about the value of the party for Kim with this information, with her belief that 40% is likely going to be sunny and 60% it is going to be rainy, is the certainty equivalent of the best alternative. Okay, so in order to find the value of the party, we need to find the certainty equivalent for this option, and this option. And then we simply pick the highest certainty equivalent and assign that as the value of this party problem for Kim, or the value of this party for Kim. Okay, so the way to do that, first we want to find out the yield values of all these dollar amounts. The way to find that is by looking at the yield curve. Find these dollar values on the horizontal axis, go up to the intersecting point with the yield curve, and then go left to read the yield value. Okay, this is how we find these 6 numbers. And then what we need to do is to find the yield values of the deals after each alternative. The yield value of this deal after the outdoor alternative is equal to 0.4. the yield value of the porch alternative that lead to this uncertain deal is equal to 0.57, and then the the yield value of this uncertain deal is 0.63. Okay, as you can see, I've already displayed all these certainty equivalents. The way to go from yield value to certainty equivalent is to find the yield value on the vertical axis, then go right to the intersecting point with the yield curve, and then go down to find the dollar value, which is $26 4.4. $40 correspond to a yield value of 0.57. $46 correspond to a yield value of 0.63. If you are wondering how to find these yield values, I suggest that you look at the recording from part 1 of chapter 1 again. We talked about this extensively in that recording. Okay. Like I said, the value of this party for Kim is equal to the value of the best alternative, which is indoors, which is $46. Okay, here you will notice that the certainty equivalent of each alternative is below the expected value of each alternative. Okay, and here we conclude the value of the party when weather is unknown at the time of decision is the value of the best alternative, which is $46. Okay. So here, if you look at this decision of party location, outdoors or porch or indoors, Kim is uncertain about the weather. She is uncertain about the weather, but she does have a belief about the weather situation on the day of the party. Okay. What we're going to look at in today's class is to look at the value of the party when Kim does have perfect information about the weather on the party day. Or alternatively, Kim can predict the weather on the party day with 100% accuracy. How can she do that? She can get help from someone called clairvoyant. Okay, so clairvoyant provides clairvoyance, or clairvoyant provides perfect information. When we think about a clairvoyant, we assume she is competent, trustworthy, and knows the future weather with 100% accuracy. Okay, when clairvoyant says it is going to be a sunny day, 100% of the chance it is going to be a sunny day. When clairvoyant says it's going to be a rainy day, 100% of the time it is going to be a rainy day. You can rely on clairvoyant's prediction of the weather 100%. Okay? Clairvoyant is only competent in the sense that he or she can predict the weather. However, the clairvoyant cannot change the weather upon Kim's request. Okay. And clairvoyant can provide the information, the perfect information about the future weather. However, it comes at a price. Okay. So here is clairvoyant's offer. Pay me $15, then I'll tell you what the weather is going to be like on the party day, and you get this message before you choose the location. However, in order to hear about the message from me about the future weather, you will need to pay me $15 upfront. Okay. Now the question that Kim needs to decide on is, should I pay the $15 to get clairvoyance, to know the future weather for sure, or should I just go with the party problem without clairvoyance? Meaning, should I just go with the party problem like this? Okay, so that is the question posed to Kim because of clairvoyant's offer. Should Kim pay $15 to get clairvoyance? Okay, if you think about this decision, there are two alternatives, right? The decision of whether to pay $15. The first alternative is not pay. Do not pay $15 and then decide on the party location without being certain about what the weather is going to be like on the party day. The second option, the second alternative, is to pay the $15 to get an accurate prediction from clairvoyant about the weather on the party day so that Kim can choose the party location accordingly. Okay, so in order to decide which one of these two alternatives Kim should choose, she needs to ask herself two questions. What is the value of the party without paying $15 for clairvoyance? Okay, and then that is actually something we've already figured out, right? This part that we've done in the review and also in the last recording of classes for this chapter. And then the next question is, what is the value of the party when she purchases clairvoyance at $15? Okay, it is very straightforward after you figure out these two values, right? If this value is higher than this value, then Kim should not pay $15 to get clairvoyance. If this value is lower than this value, then Kim should choose this option to pay $15 to get clairvoyance. I think this is a very straightforward, logical way to decide on this question. Okay, as a matter of fact, we can draw a decision tree to reflect the question or the decision before Kim at this moment. Should Kim pay $15 to get clairvoyance? Okay, so like I said, there are two options. So here we use this square note to represent this decision. Okay, whether Kim should buy clairvoyance at $15. There are two options, like I said. The first option is do not pay $15 to get clairvoyance. Okay, and we have established that without clairvoyance, Kim essentially go with the party decision with the belief that 40% of the chance that it's going to be a sunny day and 60% of the chance it's going to be a rainy day. And we have already analyzed this big decision over here, the value of this party without clairvoyance is $46. Okay, and then another alternative for this pay or not pay decision scenario is to buy clairvoyance at $15. Okay, so what we're going to do next is to complete this decision tree by completing this lower, what follows this lower branch, which represent the other alternative. What if Kim does buy clairvoyance at $15? What happens then? Okay, so again, going forward, we're going to look at what we should put over here. Okay, now if Kim buys clairvoyance service at $15, then there are two things, like I said before, that I want to emphasize again. The first thing is Kim does not know what clairvoyance message until after she pays. Okay, before she pays, she's not sure whether clairvoyant is going to tell her it's going to be a sunny day or it's going to be a rainy day. And then she pays the $15. She learns from the clairvoyant what message is, sunny or rainy. And then depending on what the message is, she can now choose the party location with perfect knowledge about what the day is going to be like on the party day. Okay, so that gives us the overall structure of what happens after she pays clairvoyance. Okay, like I said, She pays for the $15 before knowing whether Clairvoyant's message is sunny or rainy. Here, we use this circle to represent the uncertainty that she has about what Clairvoyant's message is going to be when she pays the $15. Okay, so there are two possibilities. The clairvoyant will either tell her it's going to be a sunny day, that is represented by this upper branch. We use a quote sign to enclose the weather as sunny within it to remind ourselves that we're looking at the clairvoyant's message. Okay, going forward, whenever we use a quote sign, we're referring to either clairvoyant's message or some other person, some other expert's message to you. Okay. And then over here, the lower branch represent clairvoyant's message being rainy day. Okay. So again, there are only two possibilities in terms of clairvoyant's message. Okay. Clairvoyant either says it's going to be a sunny day, or she says it's going to be a rainy day. Okay, like I said, after Kim learns about the message, she can then decide where to have the party. Okay, so after she knows it's going to be a sunny day from clairvoyance, she can choose from either outdoor or porch or indoor. Okay, here we use this square node to represent Kim's decision on the party location after she learns that it's going to be a sunny day from clairvoyant. Okay, over here, similarly, we use this square node to represent Kim's decision point where she learned from the clairvoyant that it is going to be a rainy day. Again, her options doesn't change with respect to the clairvoyant's message. She still faces the three options: outdoor, porch, or indoor. Okay, even after she learned that the message is rainy day. Okay, and after she chooses party locations, then she will move on and prepare accordingly, and then at the party day, the weather will turn out to be either sunny or rainy. Okay, so here we preserved the two possibilities of the weather represented by this circle. Okay, note this circle, if you trace back to the beginning from this circle, it is following this path. Okay, this circle represents the uncertainty of the weather when clairvoyant tells Kim it's going to be a sunny day, and then when she chooses to have the party in the outdoor. Okay, this represents another uncertainty following this path, and this represents another uncertainty following this path. Okay, similarly for these three uncertainties. Okay, so this is the overall structure of the decision that follows the second option. Kim buys clairvoyance for $15. Okay, this is only like a structure. What we need to do, remember, we need to find the value of this branch. Okay, just like what we did for this branch. We found out the value of this branch, which is 46. We need to find out the value after this alternative, which is the value of this problem. Okay. There are two things you need to do. The first thing for this decision problem, or for any decision problem, is you need to assign probabilities at circles. Okay, circles represent uncertainties that is out of the control of the decision maker. What you can do when you look at a circle is to form a belief about the possibilities that followed from the circle. Okay, so what we need to do is to assign probability to this possibility, assign probability to this possibility, assign probabilities to these two possibilities, and assign probabilities to these two possibilities. Okay. The way we assign probabilities are the same as we learned in the chapter where we looked at probability tree. The probabilities that we assign to the branches are conditional probabilities. Okay, over here, whatever probability we assign to this branch is conditional on its path, which is Claire message is sunny. Kim chooses outdoor. Okay, so those two are the conditions for the probability that we're going to assign to this branch. Okay, if you're confused about the term assigning probability, or if you're confused about the term conditional probability, or how to find the conditions for probability, then you need to review the chapter that we talked about those concepts. Okay. Like I said, the way that we can assign these two probabilities, first I'll introduce a way that we look at these two probabilities using common sense or using sort of a word deduction. And then we will look at a scientific or sort of a more rigorous way to assign probabilities to these branches. Okay. So what I said before is that clairvoyant is able to predict the weather accurately or perfectly. If it is going to be a sunny day, clairvoyant will predict it's a sunny day without any other possibilities. Okay, if it's going to be a rainy day, clairvoyant will be able to predict it is rainy day with 100% accuracy. So in that sense, if clairvoyant says it's going to be a sunny day, then 100% of the chance it is going to be a sunny day, right? So like I said, these three numbers are conditional probabilities. Conditional on what? On this message over here. It's going to be a sunny day. Okay. And then there's no possibility that when clairvoyant says it's going to be a sunny day, it will turn out to be surprisingly a rainy day. That's why we are assigning 0 to the possibility that it is going to be a rainy day. So as you can see, there are actually no uncertainties here, right? Despite of the fact that we have put two branches to represent the two possibilities of the weather to this uncertain node, there is, as a matter of fact, no uncertainty about weather whatsoever, because these three uncertain nodes comes after clairvoyant's message that it is going to be a sunny day. Okay, that's why we have ones over here and zeros over here. Regardless, we want to put the two possibilities here just to preserve the completeness of this decision tree. Okay. And as you can see, we can assign probabilities to these 6 branches similarly. If clairvoyant, these 3 uncertain nodes comes after this branch, which means clairvoyant says it's going to be a rainy day. Well, if clairvoyant says it's going to be a rainy day, then it is going to be a rainy day with 100% of the chance. There's no surprises that it will turn out to be a sunny day. Okay, that's why these numbers are here. Now R has a conditional probability of 1 because we are following this message. R has a conditional probability of 0 because we're following a sunny day message. Okay. So now comes the question of this uncertain node. Okay, like I said, you need to assign probabilities at all the circles in the decision tree. Okay. Now the question is, before you pay the clairvoyant $15, you need to form a belief about how likely the message from the clairvoyant is this way, sunny day. how likely you're going to receive a rainy day message from the clairvoyant. If that 40% of the chance is going to be a sunny day, then 40% of the chance clairvoyant will accurately predict it's going to be a sunny day. And then 60% of the chance the message is rainy day. Okay, that's how you got these two numbers. 40% of the chance it's going to be a sunny day, so 40% of the chance you will get a sunny day message from the clairvoyant. 60% of the chance it's going to be a rainy day, so 60% of the chance you're going to get a rainy day message from the clairvoyant. Okay, these two numbers are the same with your beliefs about the party day's weather situation, because clairvoyant is 100% accurate. Okay, so this is sort of a word deduction of these two probabilities over here. Also these probabilities over here. Okay, one thing you notice is that this set of probability is the same with this set of probability, and also the same with this set of probability. The reason is Kim's choice of party location, outdoor, porch, or indoor, does not change the probability that the weather is going to be sunny or rainy. What changes the probability is the clairvoyant's message. That's why, as long as clairvoyant's message is R, quote, quote, R, then 100% of the chance it's going to be a rainy day, no matter what Kim chooses in terms of the party day's location. Similarly over here. Okay. So like I said, this is sort of a word deduction in terms of all the probabilities you see on this slide. There is actually a more rigorous way to find all these probabilities. Okay, that is what I'm going to show by using probability tree reversal. We'll start with the probability tree where weather comes first, clairvoyant's message comes second. Then we'll reverse it into the order where clairvoyant's message comes first and weather comes second. We start with the probability tree that describes the accuracy of clairvoyant's message. So here we start with the weather, which has two possibilities, which is rainy day and sunny day. Okay, let's go with S up. S represent it is going to be a rainy day. R represent this is going to be a rainy day on the party day. Okay, and previously we have established this one. 40% of the chance the day is going to be sunny. 60% of the chance the day is going to be rainy. And then now we add the second distinction, which is the clairvoyant's message. Okay, so quote, quote, S represents that the clairvoyant is going to say it's a sunny day. Quote, quote, R meaning the message is rainy day. So it's here or here. Okay. And the next step is to mark these two conditional probabilities. This is also 0. Okay, this is 0. And this is 1. This is 0. Remember, these probabilities associated with branches at the second distinction are the conditional probabilities. And then what we need to do is to mark the elemental probabilities. So 0.4 times 1 is 0.4. 0.4 times 0 is 0, 0, and 0.6. Okay, if you look at what we have on the slide, is that we need to sort of reverse the tree in such an order that clairvoyant's message comes first, and then the weather comes second. Okay, another thing we notice is that these decision alternatives, the party location choice of Kim will not change the probability of the weather that comes after it. So sort of we can ignore these options and then just do one single probability tree where the first distinction are the messages and the second distinction are the weathers. Okay, so that is why we need to reverse this probability tree into a second order where the message comes first, then the weather comes second. Okay, and then here SR, SR. And the steps of tree reversal, you should be very familiar by now, which is first, reverse the order, second, match the elemental probabilities. So here we have 0.4, 0, 0, 0.6. Next step is to reconstruct the certainty, the marginal probabilities, which is the marginal probability of a sanity message is equal to this, the sum of these two. And the probability over here is the sum of these two. And last step is to find the conditional probabilities. So the conditional probability of the weather being sunny conditioned on the fact that Claire 1 says it's sunny day is 0.4 divided by 0.4, which is 1. This is 0 divided by 0.4, which is 0. Here, 0 divided by 0.46 is 0. Here we have 1. Okay, so these two numbers are what we used for the two probabilities over here, meaning how likely is the clairvoyant going to say it's a sunny day and or it's a rainy day. And these two numbers are what we used for over here. Okay, after clairvoyant says it's going to be a sunny day, how likely it is going to be a sunny day and how likely it is going to be a rainy day. Okay, and these two numbers represent probability of sunny or rainy day provided clairvoyant says it's a rainy day, which is marked over here. Okay, after clairvoyant says it's a rainy day, how likely it is going to be a sunny day or how likely it is going to be a rainy day. Okay, so all these probabilities actually come from the tree reversal of the original probability tree, which is over here. Okay, as you can imagine, if we're looking at someone who is less capable than clairvoyant, then these two numbers might be different. Remember, there is an exercise in the previous homework where Kathy is not very accurate at predicting weather. So in that scenario, these two numbers will not be 1 and 0. It may be 0.9, 0.0, or 0.1, 0.9. In those situations, we have information of imperfect nature. And then we will also use the tree reversal to figure out all these 1, 2, 3, 4, 5, 6 probabilities to be applied to the decision tree over here. However, here we are focusing our attention to someone who can provide perfect and accurate information. Okay, so this concludes the first set of the numbers to be added to this decision tree. That is the probabilities. Okay, and the next set of numbers we need to mark on this probability tree is that the values of these 12 prospects, as well as the value of the 3 alternatives after receiving sanity message, and the value of these 3 alternatives after receiving a message of a rainy day, and finally, the value of this decision alternative, where the alternative is to buy clairvoyance for $15. Okay, so let's switch gear and then focus on the values. So generally, we start with the values at the end, just like what we did for the party problem without clairvoyance. We need to figure out the value of all these prospects after paying $15. So here, the value associated with this prospect is essentially equal to the value of an outdoor party in the sun, but minus the $15 that is paid upfront to the clairvoyant. Okay, so $100 is what the original value of the party, outdoor party in the sun is, but we need to subtract $15, okay, which gets us $85. So to clarify, this 85 is the value of this prospect. Again, this prospect, trace back to the very beginning. This prospect represents the prospect where $15 is paid out. Message is sunny. Having the party outdoor, weather is sunny. Okay, so 85 is the value of this prospect. And then the original value of this party is 0. After paying $15, we get negative $15. So negative 15 is the value of this prospect. Okay, and here, go forward. So all this, the values in the first columns are the value of the parties of the 6 original prospects in the party problem. And the second column represents the value of those prospects after paying $15 to clairvoyant. So these values are what we're going to use to value all these options and this option too, not this column. Okay. So over here, we started at the end figuring out the values of the 12 prospects. Going back one step, we need to figure out the value of this uncertain deal. As you notice, despite of us calling it an uncertain deal, this is actually a certain deal where 100% of the chance this prospect will be realized. So there is no uncertainty here, which means we can carry this prospect value directly to this option. Okay, so now the option of outdoor party after receiving a sunny day message and paid $15 is 85. Over here, the option of a porch party after receiving a sunny day message and paying $15 is 75, and over here is 25. Here, we don't need to go through the U curve to find the U value of the uncertain deal and then figure out the certainty equivalent is because there is no uncertainty over here. So now we want to put a value over here to this square node. And as we said, a value of a decision node is the value of the highest valued branch, which is 85 over here. This is also equivalent to say at this point, at this decision point, Kim should choose outdoor and will receive a $85 value by that choice. That's why we put 85 over here. The value of this decision is 85, which is the value of the party problem after receiving a sanity message. Okay, let's analyze the bottom half in a similar way. So over here, the value of this uncertain deal is just the value of this prospect because 100% of the chance we're going to receive that prospect. So negative 15 here, and this prospect is 5, and this prospect is 35. Again, we're not choosing the up values because it is not a choice. By nature, it is going to go down this way, okay? And then to value this decision, we would choose the indoor option since it gives the highest value of 35. So 35 is the value of the decision over here after receiving a rainy day message, okay? Now, what we want to do is to go one step further back, okay? What we want to do next is to find the value of this alternative, which is essentially equivalent to a binary deal with 40% of receiving $85 and 60% of receiving $35. Okay, now we have a real uncertain deal where there are positive chances to receive both alternatives. This is where we need to go through the yield curve to find the yield value of this uncertain deal and then find the certainty equivalent of this uncertain deal. Okay, so going back to Kim's yield curve, the yield value of $85 is 0.92. I will not repeat the process to find this yield value here because we've gone over this a lot of times. And the yield value of $35 is 0.51. Again, these two yield values come from the same yield curve that we used to analyze the party problem without clairvoyance. Okay, and the next step is to find the yield value of this uncertain deal, which is equal to the probability of each prospect, each possibility with the yield value of each possibility. So we use 0.4 times 0.92 plus 0.6 times 0.51. That gives us a yield value of 0.674. Okay. So the last step is to figure out what dollar amount gives Kim a yield value of 0.67674. Again, using the same yield curve that we used before. Read the yield of 0.674 on the vertical on the vertical axis, go left, go down, which will give us a $51 value. Okay, again, these squares are enclosing dollar values rather than probabilities. Okay, so this is what we know. By clairvoyance for $15 gives Kim a problem that is worth $51. Now the question can be answered. The value of the party with clairvoyance is $51 over here. And the value of the party without clairvoyance is $46, which is what we began with in this lecture. Since this option has a higher value, then Kim should go with this option. Okay. So to put together these two, again, remember this decision problem, should Kim pay clairvoyant $15, has two alternatives. Go without it. Do not pay. This represents paying. So now I want to combine these two parts into one giant decision tree, which looks something like this. Okay, over here, do not pay clairvoyant gives Kim the original party problem with three options and with the uncertainty in the weather unresolved. Okay, over here, pay the $15 to get clairvoyance give Kim this party problem, where depending on the message, Kim can choose the three alternatives. And these messages resolves the uncertainty of the weather, since now we're looking at 1 zeros rather than positive probabilities. And the way we analyzed this problem is what we just covered. Okay. So this is actually the decision tree that represents this question. Should Kim pay $15 to get clairvoyance in the party problem? Okay, so that question is analyzed by this giant decision tree. Okay, looking at this decision tree again, we have different nodes and branches. There are two types of nodes. The circles here represent uncertainties or the decision by chance, which is out of the control of Kim. And the branches that come out the circle nodes represent possibilities. Here, these square nodes represent Kim's decision node. There are alternatives or decision options that come out of a square node. and Kim need to choose the best alternative at each square node. So the square nodes are what Kim get to choose. The circle nodes are the places where Kim doesn't get to choose. She'll just face the nature as is. Okay. Typically, the way we work these decision trees are to start from the end and then work back to the beginning. So we started with asking Kim, what are the values of different prospects? These values and these values. Okay. And then we follow up by figuring out these uncertain deals, and then we figure out the decisions. So the values of each prospect are at the end of the possibility of the decision tree, and dollar values are marked with squares, and the U values are typically written with U equal to. Okay. And what we need to do on the decision tree whenever we encounter a circle node is to assign probabilities to each possibility. Okay, so that is what we did over here. 0.4, 0.6 are assigned probabilities, and these are probabilities we got from the tree reversal exercise. And the value of an uncertain deal that comes after a circle node is equal to the certainty equivalent. So the value of this deal is equal to 75. The value of this deal is equal to 46. The value of this deal is equal to 51. The way to find this part is by going through the U curves and figure out the U values of the deal and then figure out the certainty equivalent. Now, focusing our attention to the square nodes. At the square node, what we need to do is to assign values to each alternatives. Look at over here. At this square node, there are 3 options. What we did is to assign the values to these 3 options. Look at here, we have another square node. And what we did over here is to assign the values to each alternatives. 85 for this alternative, 75 for this alternative, 25 to this alternative. Okay, and over here at the beginning, we also assigned values to the 2 alternatives. The value of this alternative is the value of this problem, which is $46. The value of this alternative is the value of this big uncertain deals, which is $51. Okay, the value of the decision is equal to the value of the higher alternative or the highest alternative. So the value of this big decision problem, as you can imagine, is equal to the value of this option because this is the better option, which is $51. Okay. Okay. Now this just is a repetition of what the decision should be analyzed. Here, we want to bring a definition that's called material information. Material information is the type of information or message that can potentially change your decision. Over here, this information by the clairvoyant is material because depending on the message, Kim's best alternative changes. Okay. Hypothetically, if this is also the best alternative after a sanity message, then the clairvoyant's message becomes immaterial because no matter what the message is, Kim is always choosing the same option of indoor. In that scenario, the information from the clairvoyant, despite of being accurate, is no longer material. Okay. And actually, what you want to do is to do not pay anything for immaterial information. Now, the next question is asking, we have established that at a price of $15, okay, Kim has a value of 51. from holding the party, from having the party. Now, if we change the price to a higher price, then this value of this big party problem that comes after this option will correspondingly reduce. Okay, the price that makes this value equal to 46 is called the maximum price that Kim is willing to pay for clairvoyance message. Okay, what we can do is to gradually increase this $15 to $16, $17, $18, $19, $20, and then analyze this part of the decision tree repeatedly at each price until the value of this giant thing after paying the price is equal to $46, which means until to the point where Kim is indifferent between do not get clairvoyance versus getting clairvoyance at that maximum price. Okay, so this is consistent with the definition of willingness to pay that we have defined before. Willingness to pay is not the actual price you're going to pay. It is the maximum price that after you paid for that price, you will get zero surplus. Okay. Now, that brings us to the value of clairvoyance, finally, value of perfect information. That is the highest price that a person is willing to pay to receive the perfect information. What we need to do is to start with a point and figure out if that point, starting with a price point, like what we did, $15 over here, and then slowly adjust the price until the person is indifferent between buying the perfect information at that price and not buying the perfect information. Okay, this happens when the certainty equivalent of buying the clairvoyance at the price is equal to the certainty equivalent of not buying. Okay, this certainty equivalent is here. Okay, this represents the certainty equivalent of buying clairvoyance at the price. This represents the certainty equivalent of the party without any clairvoyance. Okay, until this two becomes equal at some X price, then X price is the value of perfect information. What you need to do to keep in mind is that if you're offered clairvoyance at the value of clairvoyance, if you pay the clairvoyance at the value of the clairvoyance, then you're break even between paying and not paying. If you pay a price if you pay a price for clairvoyance at a price that is below the value of clairvoyance, then you will get a surplus from purchasing. If you're offered clairvoyance at a price that is higher than the value of clairvoyance, then you should not purchase it, because if you do, you will have a shortage. Your welfare will be hurt. Another important note is that the value of clairvoyance is the value of perfect information. If you're offered some information that is helpful but not perfect, then the value for that imperfect information should be lower than the value of perfect information. And the value of perfect information can be zero or positive. It can never be negative, meaning it is never better to remove information. So what we have done so far is the value of clairvoyance for Kim, who is risk averse. Now this problem is much easier if we're looking at another person who has the same values for the prospects, but who are just risk neutral. Okay, so that is what we're going to look at next. So as we know, for risk neutral persons, the value of uncertain deals are equal to the expected values of the uncertain deal. Okay. If you're confused at this point, you need to review what we talked about before. What is the value of uncertain deal, and what is the expected value of uncertain deal? You need to do some review if you're confused at this point about these two concepts. So here we're looking at Jane, who have, the same values of the 6 prospects of the party. However, Kim is risk neutral, which is represented by the U values over here, okay? And this is actually Jane's U curve, okay? If we graph Jane's U curve as we did, like what we did for Kim, then we would find that Jane's U curve is a straight line, okay? A straight line U curve represents a person is risk neutral. Okay. And typically we don't use U curves like this, where at some point it is bowing upward, at some point it is bowing down. So over here, Kim is risk averse. A risk averse person's U curve is always bowing upward. Okay. And a risk loving person, Tim, that is what we named him, is a curve like this. It is going to be bowing downward. The good thing about Jane being risk neutral is that we can simplify the process that we use to find the value of perfect information for Jane in her party problem. So we're going to talk about the computational advantages of Jane being risk neutral. Okay, so here is just a review on the definition of value of clairvoyance for a risk-averse person. So the value of clairvoyance, if clairvoyance is purchased at the value of clairvoyance, then a risk-averse person would be indifferent between purchasing the clairvoyance versus not purchasing. Okay, so this is what we did. We started of guessing value of clairvoyance for Kim at $15, and then we find that the certainty equivalent of the party, if Kim purchases clairvoyance at $15, is greater than the party of the value if she doesn't purchase clairvoyance. Just go with the party location problem without clairvoyance. Then in order to bring the two sides to the equal sign, we need to increase the price of $15 to $16 until we reach this equal sign, when Kim is just indifferent between purchasing and not purchasing. Okay, that's the overall definition as well as process for a risk-averse person like Kim. That's how we find the value of clairvoyance for her. Okay, now we're going to simplify this process for Jane. The first thing to recognize is that something we learned before. For a risk-neutral person, the certainty equivalent of any uncertain deal is equal to the expected value of any uncertain deal, right? So this is something we learned at the beginning of this chapter. Okay, now we can simply replace this certainty equivalent in the definition for a risk-averse person with EV. Okay, so this is what we do. From here to here, from risk-averse to risk-neutral, we are simply replace the CE with EV. Okay, so this is not the end of the simplification for a risk-neutral person. We can even simplify this. Equation further to make things even more simpler. Okay, so I'm going to carry this line to the next slide and show you how to do that. Well, as it turns out, for a risk-neutral person, the expected value of the party with clairvoyance purchased at value of clairvoyance is equal to the expected value of free clairvoyance of the party with free clairvoyance minus that price, that maximum price value of clairvoyance. So this line is equal to this line. Okay, so this is the first step. And then going from the second equation, we can add V of C to both sides, correct? So that is simple algebra that you can apply. And then starting with this third equation, we can subtract both sides by the expected value of the party without clairvoyance. Okay, going from the third equation, from the second to the third to the fourth equation, we are simply applying algebra to the numbers represented by these three items. Okay, just don't get lost here. And then this is a very easy to apply formula for a risk-averse person. You see, in order to find the value of clairvoyance for a risk-neutral person, we can simply find the value of the party with free clairvoyance, and then we can find the value of the party without clairvoyance, and then we take the difference. That would be the maximum price that a risk-neutral person is willing to pay to get clairvoyance for that party problem. Okay. Just a careful note, going from this to this, that is only true for a risk-neutral person. For a general risk-averse person, you cannot do this unless she is a delta person. So the concept of delta person will be introduced in later chapters. But generally speaking, for a risk-averse person, the value of the party with clairvoyance purchased at V of C is not equal to the value of the party with free clairvoyance minus V of C. This is only true for a delta person. Okay, so you cannot simplify the formula for a general risk-averse person with this substitution, like what we did for the risk-neutral person. This requires a whole chapter to explain to you. So just take this in as is for now, and later we'll explain to you why this is not true for a generally risk-averse person without knowing that that risk-averse person is also a delta person. Okay, so this is just a caution note. Now go back to the value of clairvoyance definition for risk-neutral person. This is the formula that we can apply. Okay, we don't need to do the trial and error process like what we did for a risk-averse person. We can simplify the problem of solving for this value by finding this value, and then take the difference. Okay. So here I'm simply putting this formula here. Value of clairvoyance is equal to expected value of the party with free clairvoyance minus expected value of the party without clairvoyance. Okay, so this is a very much simplified formula compared to this equation of definition of V of C for a risk-averse person. Okay. Now we need to apply this formula to Jane's party problem to find the value of clairvoyance. Okay, so this is the formula again, just repeatedly displayed here to remind you guys what is the formula. And this would be Jane's party problem. Okay, just like Kim's party problem in the overall structure. And if you look closely in the decision tree for Jane, all the numbers are the same at the end, which means Jane values each prospect the same way as Kim values it. This is just a coincidence. It doesn't have to be the case. Okay. And also, if you look at this 0.4 and 0.6, that means Jane's belief about the party day's weather is also the same with Kim's. This is also a coincidence. It doesn't have to be. The two persons can disagree on the probability of the party day being sunny or rainy. It's just so that we are looking at a Jane who holds the same belief about the party day's weather and also who values each one of the 6 prospects at the same dollar values as Kim does. Okay. So now what we need to do is to analyze this decision tree for Jane. As you can see, all the numbers are here, but I'll explain to you how we got these numbers. Okay. What I'm going to do is first I'm going to blow up this upper portion, which represent the party problem without clairvoyance for Jane. Okay, so this is a blown up view of the upper part of this decision tree. So if you look at this, again, overall structure is the same as in Kim's problem. However, in order to value this uncertain deal that comes after outdoor party location, the process is simpler than Kim. Recall that in order to value this uncertain deal for Kim, we need to go through Kim's yield curve to find the yield value of this uncertain deal, then find the certainty equivalent of this uncertain deal and then mark it over here. However, for Jane, we already know that Jane is risk neutral. That is something Jane told us. Then we can simply apply the expected value of this uncertain deal as the value of an outdoor party when the weather is uncertain. Okay, so this is how we get it. The expected value is equal to probability of an outdoor party in the sun times the value of it, plus the probability of an outdoor party in the rain times the value of it. Then we add these two up, which is equal to $40 as over here. Okay, we can do this because Jane is risk neutral. Therefore, the certainty equivalent of outdoors, this outdoors option, is equal to the expected value of this outdoor option, which is $40. Similarly, we can apply the expected value formula for the porch party. That's how we got the $48. Then we can do that for this indoor party option. That's how we got $46. Okay, as it turns out, for Jane, who is risk neutral, indoors is no longer the best option. Porch is the best option. Okay, recall for Kim, indoor is better than porch than outdoor. However, for Jane, porch is the best option. Therefore, the party value for Jane is equal to the best alternative value, which is 48. That's why we put 48 over here. Okay, so this is how we figure out the value of this party without clairvoyance is equal to the value of a porch party when facing uncertainty in the weather, which is $48. So this concludes the analysis of the upper part of this tree here. See, $48. Now we're going to blow up the lower part of the tree and figure out what is the value of the party with free clairvoyance. Okay, then the difference between these two values will be the value of clairvoyance. Okay, so I'm going to blow up the lower portion where we look at the party problem with free clairvoyance for Jane. Okay, we need to go through the same process as we did for Jane. So we start at the end, then we try to value these 1, 2, 3, 4, 5, 6, these 6 deals. As it turns out, similarly to Jane's problem, these are no longer uncertainty because it follows the clairvoyance message, which is very accurate. Again, the tree reversal process for Jane is no different from the tree reversal process for Kim. Okay, that process is the same, no matter if you're risk averse, risk neutral, or risk loving. That is simply science. Okay, so now the value of this is equal to 100. Value of this is equal to $90, and then go on and go forth. Okay, and again, we're looking at free clairvoyance for Jane. That's why we don't have to subtract anything at the end of the tree, because clairvoyance is offered to Jane at a value of equal to 0. And then go further back one step. In order to value this decision, we need to figure out the best alternative is outdoor party. So that's why we put 100 over here. And then in order to value this decision, we find the best alternative, which is indoors, which is equal to $50. Okay, that's how we got the $100 and $50. Then going back one step further to the beginning, this is again where Jane's risk-neutral property comes in handy. Remember, at this point for Kim, we need to go through the yield curve in order to find the value of this uncertain deal. Okay. However, here, for risk-neutral Jane, we don't need to go through the yield curve. Again, for this uncertain deal, the certainty equivalent is simply equal to the expected value. So we can simply take the probability of this upper branch with the value of the upper branch. That is 0.4 times 100. And then the probability of going down this lower branch times the value of the lower branch, which is $50. That gives us $70. Okay. For Kim, we need to find the U value of this, the U value of this, then find the U value of this uncertain deal, and then go to the yield curve to find the certainty equivalent. Don't need to do that for Jane because we can apply the expected value formula since Jane is risk neutral. That's how we get the $70. Okay. So now we have analyzed the lower part of the tree. So putting them together, this is what we get. The value of the party problem with no clairvoyance is $48. The value of the party problem with free clairvoyance is $70. Okay, that's what we got here. And simply applying the formula that we have derived generally for a risk-neutral person, we can take the difference between these two and get the value of clairvoyance. So the value of clairvoyance for Jane is equal to $22, which means Jane is willing to pay up to $22 for perfect information or for clairvoyance. After paying $22, if we subtract $22 as the cost to acquire, to buy clairvoyance, then this value will be equal to 48. Okay. So again, if we know Jane is risk neutral, then no U values or U curve is needed for Jane in this graph. Again, for Kim, we cannot even start by applying this formula because there is no such relationship that you can take differences. All you can do is to start with a guess and then adjust it upward or downward based on the relationship of these two values. So we're looking at another example for a risk-neutral person and how we can conveniently and easily use expected values to value different alternatives for a risk-neutral person when she's making an investment decision. So over here, as you can see, there are 3 alternatives. So a person is contemplating where to put her money into investment, either to invest in an apartment building or an office building or a warehouse. Okay? And what this person has in terms of information is the past economic reports, and after that, the person will have a judgment about how the economy is going to be like in the future, whether it is going to be a good economy or it is going to be a poor economy. Okay, and this is all the information that this person has gathered. Okay. So look at here, states of nature, which means we're looking at an uncertainty in terms of economic conditions. There are two possibilities for it, a good possibility and a bad possibility. Point 6 represent the investor's belief on the probability that the economy is going to be good. And point 4 represent the investor's belief that the economy is going to be bad. These two are the probabilities. And here we have 3 alternatives for the investment. And these values, these 6 values represent the investor's profits in different combinations of investment and economic condition. Okay, if the investor invests to build an apartment building, and if the economy turned out to be good, then her profit is $50,000, and this is when it is going to be a bad economy, $30,000. Maybe the people are paying lower rents or something, or there are vacant apartments in the building. And over here, if the investor invests to build an office building, and then in good economy, he'll be able to rent it out and then earn a $100,000 profit. If the economy is bad, he'll not be able to rent it out and he'll suffer a loss of $40,000. And if she decides to invest it into building a warehouse, then in good economy, $30,000, in bad economy, $10,000 her profit. Okay. Now the question is, which one of the 3 options is the best for the investor, given these values and given the 2 probabilities? Naturally, we can think of this as a decision problem. Okay, we can find the value of apartment building given the uncertainty, the value of an office building given the uncertainty, the value of warehouse given the uncertainty. Okay, and when we say the value of these 3 alternatives, we can just calculate the expected value of the 3 alternatives, since this investor we are looking at is risk neutral. That is what the investor told us. Okay, she told us she's risk neutral. As her consultant, we just need to figure out the expected value of the 3 options and present it to her. And to remind you, the expected value is just the weighted sum of the 2 values. Okay. Over here, the expected value of the apartment building investment is 0.6 times $50,000 plus 0.4 times $30,000, which is $42,000. And the expected value of office is equal to 0.6 times $100,000 plus 0.4 times negative $40,000, which is equal to $44,000. And the expected value of warehouse is equal to $22,000. Now, the risk-neutral investor would pick the option with the highest expected value, which is this office building. Okay. What if the investor is risk-averse? Then probably will have a higher certainty equivalent for the apartment building option compared to the office building option. But however, we do need to ask this risk-averse investor what her yield curve is like in order to figure out precisely what is the value of the 3 options for this risk-averse investor. And then we will choose the option that has the highest certainty equivalent. Okay, note here, when we are looking at a risk-averse investor, we look at the certainty equivalent of the 3 options rather than the expected value of the 3 alternatives. Why? Because the certainty equivalent is different than the expected value for a risk-averse investor. For a risk-neutral investor, the certainty equivalent of each option coincides with the expected value. That's how we can replace the certainty equivalent with just the expected value for a risk-neutral investor. Okay. You might be interested to say what it is like to sort of draw this problem in the form of a decision tree. Okay, so that is what this looks like. A purchase decision or an investment decision has 3 options, okay, the same 3 options. And then after choosing each option, when you're choosing the investment location or alternative, there are some uncertainty about economies, okay, good economy, bad economy. And this is the value of the prospect combined by an alternative and a possibility. Second prospect, third prospect, fourth prospect, 6 prospects over here. Again, we are using circles to represent uncertainty and square to represent decision. Okay. And then the value of each alternative after the square nodes are the expected value of the uncertain deal that come after it. Okay. The expected value of this uncertain deal is $48,000. Okay, so this one has the highest value. Oops. This number might be wrong. Okay, this should be $44,000. Okay. And then we simply choose the branches that has the highest expected value. If you're interested, you can sort of figure out what is the value of perfect information for a risk-neutral investor in this situation. Okay, so I think we can do that over here if you're interested. So this is the value, this is the investment decision without perfect information, and the value is $44,000. Now, what if we have perfect information for it? Okay, now we have free clairvoyance. Then, after free clairvoyance, you either get a message that it is going to be a good economy or it is going to be a bad economy. And then after the good economy, you will have 3 decisions, and then you will also have 3 options over here in terms of where to put your investment. And after each one, you will have the actual distinction of the economy. Okay, over here, this is apartment building, office building, and warehouse. Apartment, office, warehouse. This is a good economy, and a bad, and good, bad, good, bad. Okay. Okay, So again, there are two sets of numbers we need to mark over here. So as we can see, a good economy has a chance of 40%, 60%. So here, the message that is going to be good is 0.6. This is 0.4. If clairvoyant says it's a good economy, then 100% it's a good economy. And if the clairvoyant says it's a bad economy, then 100% it's a bad economy. Okay, so this completes the probabilities. Then the prospects. Now we're looking at free clairvoyance. The prospect value is just the same, okay, 50, 30. I'm going to write it in terms of $1,000. What is the value here? 30, 10. Okay. And then what we need to do is to start from the end and then figure out the values one step ahead and another step ahead and another step ahead. So over here, the value of this uncertainty is equal to just the option that is going to be happening for sure. Okay, so we have 50 here and then 100 here. And then here, 30. Again, I'm using squares to enclose the dollar values. Over here, the value of this uncertainty is equal to $30. And over here, negative 40. Over here, 10. Okay, now we have figured out the values over here at this step. Then we go further one step back over here. So the value of this decision is the value of the best alternative, which is $100. Okay, so $100. The value of this decision is equal to the value of the highest prospect. The best alternative, which is $30. Now we have completed this step. Then go one step back. The value of this free clairvoyance is just the value of this uncertain deal, which is equal to 0.6 times $100 plus 0.4 times $30, which is $72,000. 60 plus 12, $72,000. Okay, so this is the value of the investment with perfect information and free perfect information. Now, what is the value of the information? That is the difference between the value of the investment decision with free clairvoyance minus the value of the investment without clairvoyance, which is $44. $44,000, okay? So now the value of clairvoyance is equal to the value of free clairvoyance, which is $72,000 minus $44,000, which is equal to $28,000. Okay, so this is very helpful. If the investor knows someone who's always accurate about economic condition predictions and who's also an honest person who will not lie, then the maximum price that the investor should be willing to pay for the clairvoyance is $28,000. Okay. And you can do something like like this for almost every decision problem. Okay. So that is the example that we just looked at. Okay. As the last thing, you will be looking at this decision problem in your next homework problem set, which is problem set 5. This is the 4th question in problem set 5. So we're looking at a decision maker whose name is Stuart, and this Stuart person is risk neutral. Okay. Now the first question is, what is Stuart's value in this decision? Okay. The way to do that is, again, to start from the end, where we look at all the uncertainties and all the decision alternatives, and this is certainty. Look at the decision alternatives, mark the value of those, look at the uncertainties, mark the value of those, and then going back to this part. So what we need to do is to start from over here in distinction D. We need to figure out what is the value of this uncertain deal represented by this circle D, which is just equal to the expected value of this uncertain deal, since we're looking at a risk-neutral decision maker. That will be 0.5 times $300 plus 0.5 times $100. And that will be the value following this alternative. Okay. And then the value of this alternative is just $125. Comparing the value of these two alternatives, the higher value would be the value of this decision node. Okay, and then going back, the value of uncertainty B would be 0.3 times $150 plus 0.7 times the value of square C. Okay, and then that value would be the value of this alternative stemming out of decision number A. Okay, and the other alternative is $175. So by comparing these two, the higher value would be the value of this big deal for Stuart. Okay, so this is how you answer the first question. What is Stuart's value of this deal? Again, value is another term for certainty equivalent. Mark it, just carve it in your head that whenever you say value, it's equal to certainty equivalent. Specifically for a risk-neutral person, certainty equivalent is further equal to expected value. So that is how you comprehend all these 3 different concepts. Okay, so the second question is, what is Stuart's willingness to pay for clairvoyant's message for uncertainty B, but before she's making the decision at decision node A? Okay, so the timing of this information comes before he proceeds to make to choose from the 2 options at decision A. Okay, in order to make that a little bit easier to illustrate, I'm going to sort of do it on the paper, and I'm going to name all these branches in order to clarify. Okay, so this is what I'm going to name. The most important matter here in the naming of all these branches are the 2 branches that come after circle B. So this possibility, I'm naming it B1. This possibility, I'm naming it B2. Okay, so clairvoyant is going to tell Stuart for sure whether B1 is going to happen or B2 is going to happen for this uncertainty B. And the timing of this message comes before making decision A. Okay, so that gives us a big question. And the way to answer that question is to draw the decision diagram for this big problem first. Essentially, this decision A comes after receiving the message from the clairvoyant in terms of the realization of uncertainty B. So this is what it looked like. Okay, so here quote quote B represent the distinction of the clairvoyant's message. There are two possibilities. The message is that B1 is going to happen. The second message is that B2 is going to happen. Okay. After receiving the two messages, steward can make a decision at point A and then going forward, and at over here going forward. So this decision problem is going to change in some parts after receiving the two messages. Which part? Well, these values won't change, okay? Different scenarios still yield the same value to steward. It is this part, okay? So remember, the message is with regard to the possibility of uncertainty B. So if the clairvoyant says that the probability, if the clairvoyant says that B1 is going to happen, then here the probability that B1 happens should be 1. And the probability over here that B2 happens should be 0. So this is what changes from the original part. If you look at the original question, without clairvoyant service, at this part, at this circle node, these two probabilities are not 0 1s, meaning there are uncertainties with regard to uncertainty B in this decision problem. Versus over here, after the message of B1, this uncertainty is resolved. Actually, when steward is making a decision at this point, he look at this option, he knows this part is not going to happen. And if he chooses up, he knows that the decision situation will go along this way, which is equal to $150. Okay, and then the other option is over here. He knows it's $175. Okay, and then over here at the bottom part, which comes after the message that B2 is going to happen, then the thing that changes is over here. So this is 0, this is 1, meaning as long as the clairvoyant says it's going to be B2, then 100% of the chance B2 will happen. And then steward knows when he's deciding at point A, he knows that the decision tree will go along this path. Okay, so what he needs to put over here is the value of this part. Okay, I'll leave it to you to figure out the value. Okay, so this is 0.5. What you need to do is first to figure out the value of this uncertainty D, which is 0.5 times 300 plus 0.5 times 100, which is $200. And this other alternative at decision C is 125. So the value of this decision C is the value of the higher alternative, which is $200. And then this option B is coming this way, which means this option will lead to $200. And over here, it's 127.75. So steward will decide to go up at this decision point after receiving a message of 2, versus over here at this point, after receiving a message of B1, steward will decide to go along this path. Okay, so the value of this would be 175. Over here, it would be $200. Again, the value of the higher alternative, Now the question is, how likely will steward receive a message of B1, and how likely will steward receive a message of B2? Over here, from the decision problem, we know that 0.3 is the probability that B1 will happen. And again, clairvoyant is predicting 100% accurate. which means 30% of the chance clairvoyant will predict it's B1, 70% of the chance clairvoyant will predict it's B2. Now, the value of this decision problem with perfect information for B would be equal to 0.3 times 170 plus 0.7 times $200. Okay, so figure out what is this equal to, and then use this value minus the value of the original decision problem. That would be the value of clairvoyance for uncertainty B before the decision A. Okay, so this is how you answer this other question in problem 4 of homework 5. Okay.